Hey guys, so today we are still learning more about the atom. So our objective is that we will analyze the role of the subatomic particles so that we can predict how atomic irregularities will impact an atom's properties. And we're still on standard SAP 1E, which states develop models by analyzing patterns within the periodic table that illustrate the structure, composition, and characteristics of atoms and simple molecules. All right, so before we really get into what's new, we're going to review a little bit. Okay, so we have learned that an atom consists of a nucleus, and inside of the nucleus, you have protons. Protons have a positive charge, and neutrons. Neutrons have a neutral or no charge. Protons and neutrons make up the atomic mass of the atom. So if I wanted to figure out what the atomic mass was, I could just add up all of the protons and the neutrons, all right? And then you have electrons, which are negative, and they live outside of the nucleus in this electron cloud, all right? So in this slide, the red and the green are the protons and the neutrons, and then these little blue specks in this cloud-like structure are the electrons, all right? There you go. All right, so we have learned that protons are the identity, or they identify the element. That means when you change the number of protons, you change the element. If you add a proton, it's a brand new element, all right? That also changes the atomic number, which also changes the atomic mass, all right? So if you change the protons, you change the element, you also change the atomic number, you also change the atomic mass, okay? So now that we know about protons, we are going to focus on neutrons, okay? So we're learning about isotopes. All elements of an atom have the same atomic number and the same number of protons. We know that. The atomic number tells us how many protons we have. If we change the protons, we change the element, okay? However, atoms don't necessarily have the same number of neutrons. Neutrons live inside the nucleus. Atoms with the same number of electrons and protons, but a different number of neutrons are called isotopes. Let me say it again. Atoms with the same number of electrons and protons, but a different number of neutrons are called isotopes. Different isotopes belong to the same element because they have the same number of electrons, which means that they all behave almost the same in chemical reactions. Sorry, y'all, my dog is barking in the background. Okay, so atoms that have the same number of protons but have a different number of neutrons, and therefore, atoms have a same number of protons but have a different number of neutrons, also have a different atomic mass, because remember, atomic mass is protons plus neutrons. So if you change the amount of neutrons, you change the atomic mass. So these are three isotopes of hydrogen, all right? So if you're looking at the first one, you can tell it has one proton and one electron, all right? Now, if we look at the second isotope of hydrogen, you can see that there is a new circle in the nucleus. That would be a neutron, all right? So one proton, one neutron, one electron, because when you have an isotope, the protons and the electrons stay the same. The neutrons are what changes. So for the first one, this atomic mass is protons plus neutrons, so 1 plus 0. So the atomic mass of the first isotope is 1. The atomic mass of the second isotope is 1 proton plus 1 neutron, which is 2. And if you look at this third atom, the atomic mass of this third isotope is going to be 1 proton plus 2 neutrons. So 1 plus 2 is 3. And as you can tell, all of these hydrogen atoms have 1 proton and 1 electron. The only difference is the number of neutrons, which makes it an isotope. There we go. Okay, so we know atoms of the same element have a different mass if it is an isotope. If it's an isotope, they also have to have the same number of protons and the same number of electrons, all right? So what you're seeing right here is carbon, and we know that because the element symbol for carbon is C. The atomic number is always the smaller number, so we know the atomic number is 6, which means it has 6 protons. Boom. Boom, they're the same. But as you can tell, the atomic mass is different. The atomic mass of this isotope is 12, while this atomic mass is 14. And so I know number of protons never changes. Therefore, the only thing that could be changing this atomic mass is neutrons, right? So I already know, because to find the neutrons, I can do atomic mass minus atomic number. 12 minus 6 means this one has 6 neutrons, while this one has 8 neutrons. All right, so the way you have seen this written, you see how it says boron-10. This is how you write isotopes, okay? So boron-10 tells me it has 5 protons and 5 neutrons. Remember, protons do not change when you have isotopes. Boron-11, because I know protons don't change, I know it has 5 protons. The only thing that could have changed is neutrons. It has 6 neutrons. So if you haven't figured it out, the 10 and the 11 are the atomic masses. All right, so this is just telling you or showing you exactly what I talked about. When you are having an isotope, you write it in this type of notation where you show the name of the element and then a hyphen and then the mass number. Here are some more isotopes. While most atoms have the same number of protons and neutrons, some do not. Some atoms have more or less neutrons and protons, and those are called isotopes. An atomic mass number, that number that you see on the periodic table with the decimal, like 7.54, is actually the total number of protons plus the average number of neutrons. So the atomic mass is an average of all the different isotopes the element can have. So for instance, hydrogen, I believe the atomic mass is like 1.01. That is an average of all the 3 different isotopes that hydrogen has. Okay, so if we change the number of neutrons, we change the nucleus, because neutrons live in the nucleus, which alters the atomic mass, which makes it an isotope. And just to go over this one more time, this is how you read the periodic table tau. So they'll give you atomic symbol. That's Al, one capital letter. The other letter, if it has 2 letters, is going to be lowercase. They give you the atomic number. That's always a smaller number. The atomic number tells you how many protons you have. And if the atom is neutral, it also tells you how many electrons you have. And then you have the average atomic mass. Remember, that is an average of all the different isotopes that this element could have. The average atomic mass for aluminum is 26.981. Let me go back. The atomic mass is protons plus neutrons. All right, so if we are counting protons, neutrons, and electrons, we know this. The protons is always going to equal the atomic number. Neutrons is the mass number minus the number of protons, or mass number minus atomic number. And we'll get to electrons, just not today. We are going to do a quick quiz. Isotopes are atoms of the same element that have different, and if you said masses or neutrons, you would be correct. Okay, so we're going to do practice here, all right? And I'm going to write this down. So tungsten is an element. The atomic symbol for tungsten is W, all right? So I know the atomic number is a smaller one. It's 74. And then the atomic mass, I want to round to a whole number, is going to be 184. All right, so number of protons, number of electrons, number of neutrons is what we are going to figure out. And I'm going to get out of this and go here. Let's see if it's working. There we go. All right, so I'm trying to figure out my protons, neutrons, and electrons. My protons is always going to equal my atomic number. So that means I have 74 protons. That means I also have 74 electrons, because we're talking about a neutral atom. In order for me to find my neutrons, I'm going to do atomic mass minus atomic number. Big number minus small number. So that's going to, sorry, y'all, trying to get it all. There we go. Atomic mass is 184 minus 74. Quick math leaves me with 110 neutrons. All right, we're going to go back to the PowerPoint. Let's see if we got it right. If it wants to present, maybe. There we go. All right, so if we were to check our work, Once that goes away, you'll see that we were correct. 74 protons, 74 electrons. I don't know how to make this go away. And it should say, sorry, it should also say 110 neutrons. And we're going to stop there because we're going to do a lot more practice in class because my computer's freaking out anyway. So I'll see y'all in class.